Hello, everyone. This is our test 4 practice problem for module 7, 8, and 9. Questions are all over the place from module 7 and 8 and 9. So we're just going to solve it. And I expect you on the test to first read your problems and respond to the question that is asked. And in this video, I will make sure that I review with you all the steps for each question. And then after you finish that, you can go on MyLab Math, solve the practice problem for test 4, get 85% or better with your own work. It's not using any support to do it, and you can do it multiple times until you get your credit, your score to 85% or better, and then you would get the 10%. But I guarantee you, if you can get 85% of you doing these questions of the practice, there is nothing that will stop you from getting a decent, or why not a perfect score on your test number 4. So let's get started for number 1. Number 1, find the domain of the rational functions. Function f of x equals 7x over 9 minus x. So for rational function, to find the domain, you need to set the condition that is the denominator cannot be 0. So 9 minus x cannot be 0. And then now we want to isolate x, subtract 9 on both sides. Negative x not equal to negative 9. And then if we divide by negative 1, x should not be 9. So 2 ways to give your solution, but I just want one of them, which is the interval notation. So I want interval notation. So domain is all real numbers except 9. So that's the set of x such that x is a real number. And x is not equal to 9. And interval notation of the domain which is what I require for your answer on the test, is if we consider the number line, negative infinity, 9, positive infinity, which is the whole number line, 9 is excluded. So your domain is going to be from negative infinity to 9. Excluded means parenthesis on 9, union from 9 to infinity. So that is your domain. I want interval notation for your domain. So that's why the next problems, I'm only going to show you the interval notation. I believe MyMathLab would want you to give this, just you type in the values, but in the test, you will be required to give the domain in interval notation, which is this right here. Okay, so next problem. Still, they want you to find the domain of the function, the rational function, c of x equals x plus 9 over x squared minus 1. So the domain will be the denominator, x squared minus 1 should be not equal 0. So factored form, this is the difference of squares, so that is x minus 1 times x plus 1, that should not be 0. So x minus 1 not equal 0, and x minus plus 1 not equal 0. So x cannot be 1 and x cannot be negative 1. So on the number line, how you're gonna see it is from negative infinity, you're gonna get 1, negative 1, and then there will be 1, and then infinity. So you got 3 parts of your interval that will exclude negative 1 and positive 1. So your domain in interval notation is from negative infinity to negative 1 excluded, union from negative 1 to 1 excluded, and then union from 1 to infinity, still excluded. Excluded means that you keep a parenthesis with the numbers. So that is your domain in interval notation, which is required on the test. Not this one, but the interval notation. So next problem is to simplify. Well, you remember when I was simplifying expression in the class, first thing to think of is that you need to factor completely. Let's factor anything that we can. Sometimes you need to factor GCF, sometimes you need to use factor by grouping. It depends on what type, but you need to make sure you remember all the factoring tools that we learned in module 5 and we also used in module 6 to solve equations. So in this one here, we're going to factor the GCF, 7 in this case, so x minus 2, and GCF in denominator is 6, so that's y, sorry, that's y minus 2, and then y minus 2 when you factor 6 out in denominator. So x minus y minus 2, simplify it, 7/6 being the result. So that's the answer. 2 steps, you factor, simplify, and write your final answer. This one, we're gonna factor completely the numerator. So you can multiply 2 and negative 30. 2 and negative 30 is negative 60. Two numbers that multiply to give negative 60 and add to negative 7. So if we need to find these numbers. So 60 negative, what are two numbers that multiply to give me negative 60 and add to get negative 30? We know the larger number should be negative. So we're gonna try to see for, we know 2 doesn't work. 2 and 30, 2 doesn't work. We know 3 and 20. 2 and 30 doesn't work. Don't work. 3 and 20 will not work. 4 and 15 well, obviously 1 is negative. We know the big ones are negative. 4 and 15 will not work. Say 5 and 12 would work. All right, 5 and negative 12 will be the two numbers. So I found the two numbers, which is 5 and negative 12. So now I'm going to use these two numbers to break down the middle term into two terms to factor by grouping. So that is 2x squared minus 12x plus 5x minus 30, right? By grouping, we can group these two terms. That's the GCF is 2x factor x minus 6. GCF for the second group is 5. So x minus 6. So the factored form of the numerator of this is 2x plus 5 factor x minus 6. So we factor out the 6x minus 6 again here, so we can get the factored form of this. So that's the completely factored form. Now that I have the numerator factored, I can do the same thing in denominator. But since the coefficient of x squared is 1, we can just break down the 6 into two factors that add up to negative 7. So that's negative 1 and negative 6. And then you have x minus 6, x minus 1. The factor x minus 6 is common with denominator and numerator, so we simplify. So 2x plus 5 over x minus 1 is the simplified form of this expression. So next problem. Simplify the expression. You remember that when you simplify, first thing to do is to factor completely, and then after factor, you can after you factor completely, then you can simplify the common factors. So what do you do here on numerator to factor? Multiply negative 2 and negative 3, that's negative 6, and find two factors of negative 6 that the sum is negative 5. Two factors of negative 6 that the sum is negative 5 will be 1 and negative 6. So then you break down the negative 5x as negative x minus 6x. So 2x squared minus 6x, if you want, plus x minus 3. Factor out, group these two and these two, and factor out the GCF from each group to x, factor x minus 3, and that's just gonna be 1, x minus 3, and then your factored form is x minus 3 when you factor out the x minus 3, factor 2x plus 1. The numerator here is factored into x minus 1 minus 3, factor 2x plus 1. And then denominator, we can use by grouping again to factor it. So that was the numerator. In our denominator, we will factor it out as well. We can automatically factor by grouping, right? So the GCF of the first group is 2x squared. 2x squared factor 2x plus 1, and then plus 1 times 2x plus 1, and we factor out the 2x plus 1 to get 2x squared plus 1. 2x factor plus 1 factor 2x squared plus 1, and denominator is factored as 2x squared plus 1 times 2x plus 1. 2x plus 1 simplify, and x minus 3 over 2x squared plus 1 is the simplified expression of the rational expression. The next problem is to multiply. Well, to multiply, we still need to factor completely each expression on numerator and denominator, and then after that you will look for common factors that you simplify, and then write your simplified expression that you cancel out, and then write out your simplified expression. So that said, we will factor the GCF 15 from the first expression on top for the first fraction. So that's x plus 1 when we factor x 15 out. And when we factor 16 out of the bottom expression, we got x plus 2 inside of the parentheses, times 4 is the GCF of the top of the second fraction, x plus 2, and then 5 is the GCF, but when you factor 5 out, you would get x squared minus 1, which is a difference of squares. Then you refactor x plus 1, x minus 1. Then now we go ahead and simplify all the common factors of this expression. But when I'm looking at 16, I see that 16 can be written as 4 times 4. It's broken down as product of 2 4s. Then we will be able to cancel 1 4, right? And 15 also is factored as 3 times 5, which will allow me to cancel the factor 5 with the bottom 5 here. So cancel one of the 4s. We got 4 left in denominator. Cancel 5 and 3 left on top. X plus 2, x plus 1. And then now we can write out the remaining expression, right? So we got 3 left. That is the top number. The bottom expression here, we got a 4, and we also have x minus 1. So that is your answer for this multiplication. Here is a division. A division, like I said, is also a multiplication, but you want to keep your first fraction, change the division to a multiplication, and then flip the bottom equation, not fraction, right? So you'll get that. After this, your expression becomes x squared minus 16x plus 64 over x squared minus x minus 56 times 3, we flip it, over x squared minus 64. And then now we can factor just like we did from number 6, and then completely factor and simplify the common factors. The factored form of the first fraction, top of the first fraction, would be, what are 2 numbers to multiply to 64 and add to negative 16? So negative 8 and negative 8, because when you multiply them, it's a positive 64, and when you add, it's negative 16. So x minus 8 is the factored form of the top of the first fraction, which is also x minus 8 squared. But since I want to see all my factors, I want to keep it this laid out so that I see what factor I can cancel and what factor I can keep after I completely factor all my expressions. So, and denominator, since the coefficient of x squared is 1, we only need to break down the negative 56 in two factors that the sum is negative 1. Negative 56 will be negative 8 times 7. So when you multiply negative 8 and 7, it's negative 56. When you add them, it's negative 1. So that's x minus 8 times x plus 7. We need to factor the second fraction as well. So 3 on top. And then that's x minus 8, difference of squares, x plus 8. Now we're heading to simplifying the expression. So we got x plus 8 cancels out. Another x plus 8 goes away. Then we are left with the remaining expression that is 3 on the numerator, 3 for the top, and then the bottom is x plus 7 times x plus 8. Now we're going to do number 8, which is adding or subtracting. So two things to take into consideration when you're adding or subtracting rational expressions. Check to see if your denominators are like. If they are like, it's easy. We just save it once, and then write it as a one fraction. But if they are not like, it's going to be your responsibility to find the least common denominator. So that said, they are same here, w plus 9 once, and then you subtract or add whatever you have on top. So w squared minus 81, difference of squares. So the top becomes w minus 9 times w plus 9 over w plus 9. Simplify this, then your answer is w minus 9. Over here, number 9 is the same scenario. So you keep the denominator once, x squared plus x minus 20. In the top, you just add them because we are adding the rational expressions. So that's 4x minus 7 plus 2 minus 5x, and then simplify the top and factor the denominator. So that's negative x minus 5 over the factored form here, two numbers multiplied to negative 20 add to plus 1, coefficient of x are 5 and negative 4. So that's x plus 5, x minus 4. Then you can factor out the negative 1 here to get negative 1 out, and then x plus 5. So common factor x plus 5 gets canceled, and we're left with negative 1 on top, not just negative 1 over x minus 4 is the answer for this addition of rational expressions. Here's another rational expression that we have, right? So denominator is 4x, right? So we can move on with one fraction. 4x is the denominator, and then we would subtract the top. But what we need to be careful with is the negative sign here that will change the signs over here to negative completely. It will swap the signs in numerator for the second fraction here. The negative sign is not only for x, it's for the both terms or all the terms on top when it sits right in front of the fraction bar. Always remember that. So that is x minus 2 minus x plus 2. I mean minus 2, sorry. And then now we combine like terms to get negative 4 over 4x because we got x minus x that is 0. So then negative 1 because we simplify by 4 it's 1 times negative, it's negative 1 times 4. We're left with the negative 1 on top and the x in denominator. So that is your final answer for this addition of or subtraction of rational expression. So look at this one, right? So don't be confused here because these two are not the same. So automatically, when you don't have a common denominator or denominators are not like, it's your responsibility to find a common denominator. So least common denominator. So these two, we just have to multiply them, x plus 3, x minus 3. So your common denominator is your now denominator for the one fraction that you're going to write. And then guess what we're going to do here? We're going to make sure that since this one already had x plus 3 but did not have the x minus 3, so we're going to multiply the top of this fraction, the x minus 8, times the factor that was missing to complete the denominator here. So we would have x plus x minus 8, which is the numerator of the first fraction, times what was missing in the denominator, x minus 3, and then minus the top, x plus 1, times what was missing to complete the LCD, which is x plus 3, because we have x minus 3, we are missing x plus 3. So then we just add it on top to complete x minus 3. Now that we have this, we should distribute and simplify. So that is x squared minus 11x plus 24 minus x squared, because the sign will change. Let me put it in parentheses for everyone to see. The negative sign stays out, and then I'm performing the product of these two binomials. So that's x squared. That's plus 3, sorry. So that is plus 4x and then plus 3. And then you would see that if you distribute the negative sign, it'll change all the plus signs to negative. So then that is this over x plus 3 times x minus 3. Combine like terms on top, negative x squared, positive x squared, negative x squared get canceled. Then we got negative 15x plus 21 over x plus 3 times x minus 3. I want you to take the habit of factoring if necessary, even though at the end you may not simplify, but factoring will save you in case there would be something to simplify and then you wouldn't see it if you did not factor. So if there is a common factor, please make sure you factor it as your final answer. In this case, if you give me this, that will be your final answer. But if you give me factor the negative 3 out and give me this answer, that makes me way more happy than if you did not factor it. So that's 3 out, negative 3 I factored out. So that's 5x minus 7 over x plus 3, x minus 3. Both of them are answers, but I'm in love more with this one than the first one, which there will be no penalties if you give one or the other. Same thing happens here. We do not have a common factor, so it's our job to find it. So let's go ahead and find it. So first, let's factor completely if needed in denominator, mostly denominator. Factor always if needed. So 2 factor x minus 3, that's the 9 on top, plus 2 over 3 factor x minus 3. So your LCD, it's easier for you to see the LCD when you factor completely, would be 2 times 3 times x minus 3, which is 6x minus 3. So common denominator is x, 6 factor x minus 3. And then now we can have one denominator, one fraction, 6x minus 3. And then that is, we need to multiply the first one by 3 to get the 6 factor x minus 3. So that's 27. Plus we should multiply this one by 2 to get 6 factor x minus 3. So that is 4. So finally, answer is 31 over 6 times x minus 3. That's your answer here. How do you divide fraction? You keep change to multiplication and then flip this one. So let's try this. That equals 4 over 6x times 6x over 2. Simplify by 6x, simplify 2 from 4. That's left me with a 2 with on top. So that is just 2. Okay. Same thing happens here. 5 over 3 x minus 3 times x minus 3 over x. Simplify x minus 3 and get the answer 5 over x. When you have a complex fraction, you will probably need to write one fraction for the numerator part and one fraction in the denominator. So there is some prior work that you need to do to get this done when the equations are not 1, when your fractions are not 1 prior to doing keep, change, flip. So that's the case for this one. My common denominator for the top is x squared. My common denominator for the denominator is also x squared. Now we know that we need to multiply this one by x to get an x squared. So if we do it in denominator, we need it in numerator as well. So that's 2x plus 1. Same thing here. We multiply by x denominator to get x squared, and this needed to be done on top. So 1x. So that's 4 minus x. Now that we have one fraction for the numerator and a one fraction for the denominator, we can keep the top 2x plus 1 over x squared times the reciprocal of the bottom fraction. So that is x squared over 4 minus x. So that cancels the x squared to leave me with 2x plus 1 over 4 minus x, which is fine. But if you swap terms and factor -1 out, it's also 2x plus 1 over, there's a negative sign in front, x minus 4. But don't worry about that. You can also give me either one of these two. But remember that your negative sign here in front of the fraction bar can be distributed over 2x plus 1 to make it negative 2x minus 1, which is also one of the answers. But all of them are correct answers. If you have this also, negative 2x minus 1 over x plus x minus 4. But for all of these three are your answer. Same thing happens here. We want one fraction here, so that's 1. We multiply by x to get, and then this one, that's 1, and we multiply by x squared in order to have a common denominator. So that is my main fraction bar, x for the top, so 1 plus 3x. Denominator, common denominator is x squared, and that is 1 minus 9x squared, right? So keep change flip, 1 plus 3x over x times x squared time over 1 minus 9x squared. That is a difference of squares. So 1 squared minus 3x squared, right? So that's this. So then you can completely factor this. Keep this one, 1 plus 3x over x times x squared over 1 plus 3x times 1 minus 3x is the factored form of 1 minus 9x squared. So then one of the x's go. We got 1x left. X plus 3 cancels. Then what's left is 1x on top over 1 minus 3x. That's your answer. So number 17 is a different model. They want me to find the slope of this line. So the formula to find the slope of a line is if you have 2 points of a plane, 2 ordered pairs, x1, y1, and x2, y2, 2 ordered pairs or 2 points of the plane of a coordinate system. The slope of the line, the slope of the line passing through these 2 points is given by m equals y2 minus y1 over x2 minus x1. Okay, so if I call this x1, y1, x2, y2, using the formula, m of the slope is y2 3 minus y1 7 over x2 7 minus x1 -7 minus -2 minus -2 makes it a +2. Minus -2 turns into a +2. And then now we simplify this as -4 over 9. We got a slope that is negative. -4 over 9. So that is a line that's going to go from left to right down. Goes down because the slope is negative. Let's use the same formula here. M equals, if I call this one x1, y1, x2, y2, we will have the formula y2 -5 minus y1, negative 9, so plus 9, over x2, which is 5, minus x1, negative 3, so plus 3. So we would perform these operations. Negative 5 plus 9, that is positive 4 over 5 plus 3, 8. We simplify this, and that is 1 over 2. It's a slope that is positive. The line goes up like this on the coordinate system. The number 19, same. They want me to find the slope. So m equals, if I call this one x1, y1, x2, y2, I would have y2 negative 2 minus y1 positive 2, because it's negative by itself. And then now x2 negative 9 minus x1, which is 3, minus 3. So that equals negative 2 plus 2, that is 0, over negative 12. So that is 0. You have a line that has a slope 0. This line will be a horizontal line. So that line will intersect only with the y-axis. So that's a vertical line. And that is, this line intersect only y-axis, because it's vertical. And then the next problem here, same thing, x1, y1, x2, y2, m equals negative 7 minus negative 3 over 1 minus 1 equals negative 4 over 0. That's a slope that is undefined. A slope that is undefined gives me a vertical line. Vertical line for undefined slope. And oh, over here was the horizontal line, sorry. Horizontal line. And the vertical line is when you have a slope that is undefined, which intersects only the x-axis. So here is the summary of all of these. Positive slope line is going upward, downward for the negative slope, 0 slope horizontal line, and then slope undefined is a vertical line. And talking about the types of slope, we will, in the new set of problems, we will be using the slope to identify whether you have parallel slope or perpendicular, parallel lines or perpendicular lines. So same slope determines that the lines are parallel. So if I have y equals m1 x plus b1 and another line, equation is m2 x plus b2, then the two lines are parallel if the slope M1 and M2 are the same. I didn't say MX, M1X, M2X. I just said M1 and M2. So we're talking the coefficients of X, not X included. So if the number that is the coefficient of the X's in the equations Y equals MX plus B, but two lines are the same, that's when you say that the lines are parallel. And if one is a value, M for example, but if one is a value, say 2, and the other one is negative and then 1/2, so it's the negative, if the opposite reciprocal of these, of the first one is the opposite reciprocal of the other, you say that these two lines are perpendicular. Perpendicular when the slopes are one opposite reciprocal of the other. For example, if one of them is -2/7, and then the other one should be 7/2, one positive, one negative, and then the reciprocal of the fraction, then you know that these two lines are perpendicular. So that said, that's what we're going to use. We're going to identify the slopes and be able to determine whether you have parallel lines or perpendicular lines. For these two lines, the slopes are the same. Coefficient of X are same for both of them. These two lines are parallel. Well, for these two, we don't know yet. Well, that's why we want to put the lines in slope-intercept form. Which means Y equals MX plus B, solving for Y. So let's add 2x on both sides. Gets me to 5y equals 2x plus 4, and divide by 5. Then we got y equals 2/5 x plus 4/5. That's the slope-intercept form of this one, and we got a slope M1 equals 2/5. The second line, we can add 5x on both sides. Takes me to 2y equals 5x plus 14. Divide by 2. Get y equals 5/2x plus 7. And we have an M2 second slope that is 5/2. These two are close to be opposite reciprocal, but they're not. The reason is because if we're talking opposite reciprocal lines, we expect one to be positive, one to be negative, and the fractions are reversed. But this one, fractions are reversed, of course, but they have the same sign, +1, positive, so means it's neither, because they're neither perpendicular or parallel. Here is another example. They have this problem, right? And they want me to find the slope of a line perpendicular. So if I'm looking for the slope of a line perpendicular to one given line, I'm looking for the slope of this line and take its opposite reciprocal. But to find the slope, the easiest way is to solve it for y so we can get the slope-intercept. So subtract 3x on both sides. We got -4y equals -3x plus 12, and then divide both sides, everything, by -4. and then get y equals 3/4 x minus 3. The slope of this line is 3/4, and the slope of a perpendicular line to 3x minus 4y equals 12 is -4/3. The slope-intercept form, I'm moving to number 24. The slope-intercept form of a line gives you slope-intercept form, which means the one that is y equals mx plus b, is the form, say it's the easiest form where you can easily see your slope and the y-intercept. The coefficient of x is your slope. The number with x is called the slope of the line. And the number independent from x forms the y-intercept with the x component of this 0, and the b is the y coordinate of the y-intercept. So that's the y-intercept. That means the point at which this line will cross the y-axis. Let me say that again. Y equals mx plus b. M, coefficient of x, is the slope, and y-intercept, point at which the line crosses the y-axis, is 0, b. For example, if I have y equals 2x plus 5, the slope of the line is 2 or 2/1 certain, say, and the y-intercept is 0, +5. Well, sometimes they give you the slope and the y-intercept and ask you to find the equation. It's easy. Slope m equals -7 in this case, and that's what number 24 about, by the way. Slope equals m, -7. Y-intercept is 0, 7. That means b equals 7. So we place them into this formula to get y equals -7x plus 7 is the equation in slope-intercept form of your line. However, if the first coordinate is not 0, the point that is given to you cannot be used as slope-intercept, as the intercept. Well, here's what you do. Let's suppose that this is A and this is B, and they give me the slope m equals 9. You're going to use the point slope form, which is y minus b equals m factor x minus a, and then distribute and solve for y to find the slope-intercept form of the line. So let's do this. We're going to use this formula right here. So we got y minus b is 2 equals m, which is 9, factor x minus 5. And obviously we will distribute the 9 and add the y. So add the 2, y equals 9x minus 45 plus 2, and simplify to get y equals 9x minus 43. So that is the slope-intercept form of this equation of the line passing through 5, 2, and then with the slope m equals 9. Number 26, they don't give me the slope, but they do give me the 2 points that the line passes through. And I know how to find the slope when I know the points, the coordinates of the points. M equals y2 minus y1 over x2 minus x1. So if I call this one x1, y1, x2, y2, I can use this formula to say that my slope is -5 minus 9 over -3 plus 4, which is -14 over 7. Slope m equals -2. Now, after I get the slope, I can use the same technique that I used here, calling either one of these 2 points A and B. So I can call this one A and this one B. So I can use y equals y minus B equals m, the slope I just found, x minus A. So that's y minus -5 plus 5 equals m, which is -2 that I just found, factor x minus 3, what I call the A. But don't worry, if you use this point right here, your answer will not be different. That's why you have the freedom to decide which one of the x1, y1 or x2, y2 that you're going to use as AB in your formula. It does not matter which one you used. After simplification, your answer will end up being the same as the one who used the different AB. So it's okay. Don't worry about that. And then y equals -2x plus 6 minus 5. I subtracted 5 on both sides, and y equals -2x plus 1. That is the equation in slope-intercept form. And then they said you should give your answer in function notation. If they say function notation, you give me that, you only have partial point. I will not give you full credit if they say function notation and you give me y. Your answer in function notation is f of x or h of x or c of x or anything of x equals -2x plus 1. So basically, you should replace the y equal by f of x or h of x or c of x or d of x or anything of x equals, and then it's the same expression. Just give the function notation. And if you remember, in number 27, if you remember, they say write the equation of the line, but they say that the slope is 0. Slope 0 line is horizontal. That intersects the y, the y-axis only. That said, we don't need the x. we only have the y, and that equals y, that is y minus 2, the equation of the line that has a slope 0. This line will intersect the y-axis at y equals -2. That's how it would look like. So that's my equation, y equals -2. For a vertical line, the slope is undefined. There will be no need for the y. So your equation is x equals -4. Number 29, find an equation of the line through 2, 6 and parallel to that. Y equals 4x minus 4. Well, if it's parallel to this, that means the slopes are the same. So given that the slopes are the same, I know the slope of the line that I need the equation for. So m equals 4. So that's A and B. So I'm going to use y minus b equals mx minus a. And then plug in the values. Y minus 6 equals 4 times x minus 2. Okay, and then now solve for y. We would have y equals, we will have y equals 4x, we distribute 4x minus 8 plus 6. Combine these two, that is minus 2. And then they said, write your answer in function notation. Never forget, if it's that, you're not going to get full point if you have to write it in function notation and keep it as y. So your answer would be f of x equals 4x minus 2. Over here, they say, same question in number 30, but they say the line you need the equation for is perpendicular to that one. Well, we would divide everything by 7 to isolate y, and then you get y equals 1/7 x minus 2. Since the line that I need, the slope that I need is a line that is perpendicular to that, the slope of the line that I'm looking for is the opposite reciprocal of the slope of this line, which is 1/7. So the slope is m equals -7, negative and flip. So, and then that's A and B, right? So I'm going to write my equation y minus b equals m x minus a. So y minus -6 plus 6 equals -7 times x minus 8. And then distribute and subtract to get y equals -7x minus or plus 56 and minus 6. 56 minus 6 is 50. So, and then they said write in function notation. So that's going to be negative 7x, f of x equals negative 7x plus 50. Number 31. You have a system of linear equation where your solution can be an ordered pair, x, y. That's your solution. And that's the form you write down your solution. It's the ordered pair with parentheses inside of a pair of braces, because you use braces whenever you're listing the solution set of your equation. So the parentheses tells me that my solution is an ordered pair inside of x and y inside of a pair of parentheses, and the braces tells me that this is my solution set. So if you just give me the pair of parentheses without the braces as your solution set for the system of linear equation in two variables, you are not accurate with your answer. So make sure you do both of them. Pair of parentheses for the ordered pair, one solution xy, and then the braces tells that this is your ordered, this is your solution set. Now, what are we looking for here? They say determine whether this ordered pair 2, 1 is a solution of the system. Well, to check that, this is going to be x in your equation and y, and you need to verify it for both equations. If it verifies one and does not verify the second, you do not have a solution for the system. And your work is easy when the first equation does not verify. If it does not verify, well, your work is done, because you know whether the second one verifies or not. Since the first does not verify, the point is not. The ordered pair is not a solution, because both of them must be verified. So let's check. For the first one, x equals 2, so that's 4 times 2, minus y equals 1, so 5 times 1 is expected to be 3. Now, my work is to find this. So that's 4 times 2, 8, minus 5 times 1, 5. Is it 3? Well, yes, that's 3 equals 3. So this one verifies. I'm okay with the first one. Now let me check the second one. The second one, it's negative 4 times x, still 2, plus 3, that is y is 1, is expected to be negative 5. Negative 8 plus 3 equals negative 5. And then I see negative 5 over here, and then negative 5 here. That's checked. And then yes, the ordered pair 2, 1 is a solution of the system. So yes. Now, when it comes to graphing a system, when it comes to solving a system of linear equations, we have 3 ways to do so. Number 1, by graphing. Number 2, by substitution. Number 3, by elimination or addition. We have another way to solve it. They will call it by Kramer method. We're not gonna go there for now, but these are the 3 ways that you are going to be asked to solve. Whenever they ask you to solve a system by graphing, they will give you the graph, and then you're gonna need to graph to show your steps, graph the lines, and then find the intersection. Or if there is no intersection, there will be no solution for your equation. If there is, the 2 lines are laid on top of each other, that's when you know that all real numbers are solutions, or infinitely many solutions. So when solving, you have 3 options: no solution, the lines are parallel, infinitely many solutions, the lines are on top of each other, or a unique solution, the lines intersect with each other at a certain point. So these are the 3 types of solutions that are expected when solving a system of equation in 2 variables. So you have 3 methods to use: by graphing, substitution, elimination, or addition. For all of them, you can either have no solution, where the lines are going to be parallel, infinitely many solutions, where the lines are one on top of each other, or one unique solution, where you're going to find an xy, which is the point where the x and y corresponding to the point of intersection of the 2 lines. Now let's go ahead and see what we have over here, since they asked me to solve this by graphing. So when you're solving a system of linear equation by graphing, your first move is to find a slope and the y-intercept of each, and then sketch your lines, and then find out where they intersect. So let me get the slope-intercept form of this. subtract x on both sides. We got y equals negative x minus 3, which is slope equals -1 and intercept, y-intercept equals 0, -3. If I subtract x on both sides here, I would have -2y equals -x plus 12. If I divide by -2, then I have y equals 1/2 x -2 minus 6. Slope for this line, let me get this one in blue so we can see the colors on the lines as well. So my slope here is m equals 1/2 and y-intercept is 0, -6. So first, we want to plot the y-intercept. Y-intercept is 0, -3 for the first line in pink. 0, -3. So -1 means down 1 over down -1, down 1 because it's -1, and then over to the right +1. So that's this. And for more accuracy, I can do it another point, up, down, left, up 1, left 1. So then I can draw the line. By connecting the dots and make sure I extend them. So that's my first line. This one is y. X is x plus y equals -3. That's this one here. And then the other one has a y-intercept that is -0, -6. That's this. And the slope is 1/2, means that I go up 1 and over 2. Up 1 over 2. 1, 2. So you see, I already see where they intersect, which is perfect for me. So then I draw the line. Extend it. So I already see the intersection, which is automatically going to be my solution. So that's the x and that's the y. So that's my solution here is 2, -5. So that's the solution of the system of equation that they wanted me to solve. So let me put it in. And obviously the blue is the other line that was x minus 2y equals 12. Here's another example here. We're going to go ahead and solve it quicker than the first one. Let's solve for x. Let's solve for y. So we can see the y-intercept and the slope. Add 4x on both sides. So that takes me to 2y equals 4x. Divide by 2. we got y equals 2x. So your slope here is m equals 2, y-intercept 0, 0. So let me graph this line very quickly. That's 0, 0 here, and go up 2 over 1. If I go down 2, I would go over 1 to the left here. And then that's going to be my first line. That is my first line. 2y minus 4x equals 0. Now let's work with the second one. Subtract x on both sides. 2y equals negative x plus 5. Divide by 2. Y equals negative 1/2 of x, and then plus 5 over 2. So 5 over 2 is 2.5. So your y-intercept is 0, 2.5, and your slope is negative 1/2. Let me find 0, 2.5. So it goes up and then right in the middle, midway. Okay. And then it goes up, it goes down 1. So that's the halfway here. And then over. It goes down 1 and over 2. 1 and 2. So if we do it again, down 1 and over 2. So it looks like my solution is one of the points that I've known of already. Which is this. So this is x equals 1. Your solution is x equals 1 and y equals 2.